So for number 25, they want us to take the area bounded between these curves. So I've put this in a graphing calculator, and we can see that the area bounded between the curve root of sine y and the curve x is equal to 0 is this section here in yellow. And so they want us to take this area and revolve it about the line y is equal to 4. So when we revolve it about that line, what is going to happen is we're going to have these, we're going to take this height here and we're going to revolve it like so. So we're going to end up with these cylinders that we're going to sum up, we're going to sum them up vertically, right? So the further that I'm at, the bigger my cylinder would be, and so on. Now let me just erase that so it doesn't get too crowded here. It was just for you guys to see that we're summing up these cylinders, we're summing them up vertically, right? And these cylinders here, we can think about unwrapping them as we would do an infinitely thin sheet of paper that got wrapped around the line y is equal to 4. And so this sheet here, it has an area, right? And so our volume, is going to be the sum of all these areas. And since we're summing them up vertically, they do have to be areas as a function of y, because we're summing them up across the y-axis. So like adding the little dy's, right? And as we can see here, our sum will begin at this point at 0 and end at pi. So that is going to be our sum. So once we have this, all we have to do is we have to express the area of that sheet in terms of y, because it definitely does change as a function of y, right? Like the lower that I go, the bigger that my cylinder is going to become. And so let's think about how we are going to express this in terms of y. And so the first part is this base here. Well, this base that gets revolved, it's equivalent to this base over here. And let's think about what this height is. Well, this blue height is basically wherever it touches that curve, root of sine y, right? So for example, if I were lower here, I would revolve the height of that function, which is measured, that curve rather, which is measured from 0 all the way out to where it touches that point. So as we can see, this blue is just the value where it outputs, right? So this is just root of sine of y. Okay, so we have the base, but what about the height? And let me do this in a different color. And so this height here, well, it corresponds to this circumference, right? Because if you think about it, it's like a sheet of paper that has been cut open. So this is actually a circumference of a circle. And now any circle, the circumference is given by 2 pi r. So circumference is 2 pi r. However, we want to be able to express this radius in terms of y, because it is changing as a function of y, right? We need to be able to express the whole area as a function of y, such that, so that I can sum up across the y-axis. And so let's think about what this radius is. Well, this radius is going to begin at the line y is equal to 4, and it's going to go down here to the value of my y, right? So for example, over here at y is equal to 2, that would be my length. However, we don't really measure the y from up here. We measure it from downwards, right? So the actual length of my y is going to be measured from all the way down here up to where it meets that black arrow. So we can see here that the length of the black arrow is just the whole length of 4 minus the length of y, right? Wherever I'm at on my y-axis. So if I were at, say, y is equal to 1, right? So down here, I would go 4 minus this height of 1, which would give me 3. So as we can see here, the radius is actually the opposite, right? It goes 4 minus wherever I'm at, because we're measuring it up from the line y is equal to 4. And so my circumference is going to be 2 pi, and the radius is just going to be 4 minus y. So we have here that this is 2 pi times 4 minus y. So once we have this, we know that the area is equal to base times height, which is equal to, the base is 2 pi times 4 minus y, and then the height is square root of sine y. So once we have this expression for area, we are now ready to plug this into the integral, right? Because we're just summing up all these areas. And so this volume is going to be the integral from 0 to pi. The 2 pi goes outside because it's a constant, 2 pi. And in the integral, we have 4 minus y times square root of sine y times dy. Now, thankfully, this problem wants us to evaluate this integral using a calculator, right? It does not want us to do it by hand. So I'm using the online calculator called Symbolab. So I'm going to evaluate this definite integral, and when I do, I get that the volume is equal to 36.57476. And so that's what I get when I take that area here and I revolve it around the line, y is equal to 4.